It's been 3 years since NASA's James Webb Space Telescope was launched on its mission to investigate the earliest days of the universe.
James Webb begins a voyage back to the birth of the universe.
Really think about someone saying, let's invent a telescope that can see back to the Big Bang. Like, what?
And peer through deep time to help scientists understand how planets, stars, and galaxies are formed. What happens when they die, and everything in between. It's been a wild ride that has produced some of the most beautiful images the world has ever seen. This is what the James Webb Telescope has discovered so far. They call this the Sombrero Galaxy. Unlike visible light images that only show the galaxy's bright core, Webb's mid-infrared instrument unveils a smooth inner disk and intricate clumps within the outer ring. Still doesn't look like a hat to me, but it is cool. Astronomers have identified an exceptionally hungry black hole at the center of a dwarf galaxy from the early universe, dating back approximately 1.5 billion years after the Big Bang. Using data from James Webb, the team discovered that this supermassive black hole is consuming matter at a rate over 40 times faster than what we thought was possible. This intense accumulation, though likely short-lived, provides valuable insights into the rapid growth of supermassive black holes in the early universe. James Webb and the Hubble Space Telescope have provided this unprecedented image of Vega, one of the brightest stars in the night sky. Hubble's observation reveals a vast, smooth disk of fine dust particles, while Webb's infrared imaging detects the glow of warm dust in the disk's outer regions. Strangely, this disk lacks the clumps or gas typically associated with large planets, meaning Vega is all alone out there with a bunch of rocks. This composite image combines Webb's mid-infrared data with Hubble's ultraviolet and visible light observations, revealing intricate details of these two spiral galaxies interacting with each other. The vivid colors in the image highlight areas rich in dust and gas, essential ingredients for star formation. This is Centaur 29P, a mass of rock and ice orbiting between Jupiter and Neptune, and what James Webb has captured here is essentially a giant asteroid fart. Using the near-infrared spectrograph, Webb detected 2 carbon dioxide jets and 1 carbon monoxide jet blasting out from 29P's surface. Here we have an unusual galaxy located about 1 billion years after the Big Bang. The weird thing about this galaxy is that its gas is brighter than its stars, a phenomenon not commonly observed. Researchers suggest that this could represent a traditional phase in galactic evolution, bridging the gap between the universe's first stars and more developed galaxies. This is a pair of galaxies crashing into each other 465 million light-years away in the constellation Leo. The interaction involves a spiral galaxy and an elliptical galaxy, with the spiral's arms appearing distorted thanks to the gravitational forces exerted by the elliptical companion. James Webb has examined the outer rim of the Milky Way, known as the extreme outer galaxy. Utilizing its near-infrared camera and mid-infrared instrument, Webb captured detailed images of star-forming areas within 2 molecular clouds. These observations reveal the presence of young, massive stars and intricate structures of gas and dust at the edge of the galaxy. This is a galaxy that resembles a cosmic question mark. The phenomenon results from gravitational lensing, where the immense gravity of a galaxy cluster bends and magnifies the light from a more distant galaxy, creating this question mark shape. Initial observations from James Webb unveiled massive super bright galaxies existing just 500 to 700 million years after the Big Bang. These early galaxies appeared too large and bright for their age, suggesting an unexpected rapid formation. New research indicates that supermassive black holes at the centers of these galaxies likely contributed significantly to their brightness. The intense radiation from these black holes would make the galaxies appear more massive and brighter than they actually are. This is a gas giant exoplanet several times the mass of Jupiter and located approximately 12 light-years from Earth. With an estimated temperature of about 35 degrees Fahrenheit or 2 degrees Celsius, this is among the coldest exoplanets ever directly observed. Now, that's not to say there aren't colder planets, it just means that we're now able to see things in the galaxy that aren't burning hot stars, which is pretty cool. This is a planet where one side is always sunrise and the other is always sunset. Utilizing Webb's near-infrared spectrograph, astronomers detected a temperature disparity of roughly 300 degrees between the two sides. Any guesses which one was hotter? I would have said morning, but it turns out the sunset side is the hottest. To celebrate its second birthday, James Webb captured a stunning infrared image of these two interacting galaxies located approximately 326 million light-years away in the constellation Hydra. This galactic duo are known as the Penguin and the Egg. Their ongoing interaction, initiated between 25 and 75 million years ago, has led to significant distortions in their structure, with one's spiral arms stretched into a shape reminiscent of a penguin embracing an egg. This is a protostar, basically a baby star in its early formation stages before nuclear fusion starts. The image reveals a bright hourglass-shaped structure resulting from the protostar's outflows interacting with surrounding gas and dust. A dark, thin disk of dust cuts through the middle of the hourglass, feeding material into the growing star. This is a groundbreaking image of the Serpens Nebula, revealing multiple pairs of bipolar jets from newly forming stars. These jets appear as red streaks emanating from protostars and align closely with the surrounding gas and dust filaments. The alignment supports existing theories that magnetic fields play a crucial role in directing both the jets and the filaments during star formation. The Crab Nebula is essentially fallout from a supernova located 6,500 light-years away in the constellation Taurus. Utilizing its near-infrared camera and mid-infrared instrument, Webb captured detailed images revealing the nebula's complex structure, including filaments of gas and dust, as well as regions of active star formation. This is a pair of twin baby stars formed just 2 to 4 million years ago. The discovery was made possible by Webb's mid-infrared instrument, which also detected gas jets emanating from both stars. These are three of the oldest galaxies in the universe, dating back to between 400 and 600 million years after the Big Bang, and they are still actively forming stars. They do this by pulling in cold helium and hydrogen gas from their surroundings and fusing the elements to ignite new stars. James Webb has provided new insights into WASP-107b, a gas giant exoplanet known for being puffy like a marshmallow. Observations reveal a significant deficiency of methane in its atmosphere, suggesting that the planet's interior is much hotter and its core is more massive than previously estimated, hence its puffy appearance. James Webb has measured the wind speed on a gas giant exoplanet located approximately 280 light-years from Earth. These observations reveal that the planet, which has one side perpetually facing its star, experiences extreme temperature variations between its day and night sides. This leads to high-velocity equatorial winds, estimated at speeds up to 8,000 kilometers per hour, which helps redistribute heat across the planet. This is the sharpest infrared image to date of the Horsehead Nebula. I still don't see a horse, but the observations reveal intricate details of the nebula's so-called mane, showcasing complex interactions between gas and dust. This is a starburst galaxy located 12 million light-years away in the constellation Ursa Major. The starburst is experiencing a high rate of star formation, producing new stars at a rate 10 times faster than our own Milky Way. James Webb has detected complex organic molecules, including alcohol, in the icy regions of a molecular cloud. These findings suggest that alcohol was present during the early stages of star and planet formation, potentially contributing to the development of life-supporting environments. This is a massive star-forming region of the Triangulum Galaxy located approximately 2.7 million light-years from Earth. This region is home to over 200 young massive stars, all in the early stages of their development. We are looking at one of the brightest and most distant known galaxies existing just 430 million years after the Big Bang. James Webb has provided compelling evidence for the presence of a neutron star at the heart of a supernova. This supernova, first observed in 1987, has been extensively studied, but the nature of its core remained uncertain until now. Researchers analyzing data from James Webb have discovered that many early galaxies look like pool noodles or surfboards. This is a dust cloud that looks like a cat's tail. Astronomers using James Webb have detected an aurora over the north pole of a solitary brown dwarf located 65 light-years from Earth. This finding suggests that the aurora, similar to Earth's northern lights, may be heating the upper atmosphere of the star. Unlike planets, brown dwarfs lack a host star to drive these atmospheric phenomena, indicating that the light is generated by the brown dwarf's own magnetic field interacting with ionized gas in its environment. James Webb has been pointed at Uranus, and it's seen things. The near-infrared camera revealed 11 of the planet's 13 known rings, including the faint Zeta ring, showcasing Webb's sensitivity to such delicate structures. This is a high-definition image of what's left behind after a supernova. The near-infrared view reveals intricate details of the expanding shell of material from the exploded star, including bright pink and orange clumps composed of elements like sulfur, oxygen, argon, and neon. This is a Herbig-Haro object, a bright region surrounding a newborn star or protostar. Herbig-Haro objects form when jets of gas from protostars collide with nearby gas and dust at high speeds, creating shockwaves. JWST has unveiled unprecedented details of our own galaxy's core. Utilizing its near-infrared camera, Webb's observations reveal approximately 500,000 stars, along with previously unidentified features like these crazy blue needle-like structures. Here we have another collaboration between James Webb and Hubble to produce this vibrant, comprehensive image of a galaxy cluster. By merging Webb's infrared observations with Hubble's visible light data, this panchromatic view spans wavelengths of light that are almost imperceptibly small, revealing a vivid landscape of galaxies. Here we have found an unknown high-speed jet stream in Jupiter's atmosphere. This jet stream, located above the planet's equator and spanning over 4,800 kilometers in width, exhibits wind speeds reaching 515 kilometers per hour. Positioned approximately 40 kilometers above Jupiter's main cloud decks, this discovery offers new insights into the complex atmospheric dynamics of the gas giant. Carbon dioxide has been detected by James Webb on the icy surface of Jupiter's moon Europa, specifically in the region known as Terra Regio. This finding suggests that carbon likely originates from Europa's subsurface ocean rather than external sources like meteorites, and carbon is an essential building block for life. This is Earendel, the most distant star ever detected. It's located in the Sunrise Arc galaxy 28 billion light-years away. Utilizing its near-infrared camera, Webb identified Earendel as a massive B-type star, more than twice as hot as our Sun and approximately 1 million times brighter. The star's light emitted within the first billion years after the Big Bang has been magnified by gravitational lensing, allowing for this unprecedented study. This is a galaxy cluster commonly known as El Gordo. The immense gravitational field of El Gordo acts as a lens, distorting and magnifying the light from background galaxies, resulting in prominent gravitational arcs. This is another Herbig-Haro object created by a pair of actively forming young stars located approximately 1,470 light-years away in the constellation Vela. The image reveals intricate details of the star's bipolar jets, which have been ejecting material in opposite directions for thousands of years. These jets interact with surrounding gas and dust, creating shockwaves that produce these vibrant colors. James Webb has detected water vapor in a distant solar system, and it's found within 100 million miles of the host star, the region where rocky planets like the Earth typically form. This is the first time water has been observed in the Goldilocks zone of a disk already known to host 2 or more protoplanets. To commemorate its first birthday, James Webb captured a detailed image of this cloud complex, the closest star-forming region to Earth. This high-resolution image reveals numerous protostars and their energetic jets interacting with surrounding interstellar gas, illuminating molecular hydrogen in red hues. These are 2 dusty supernovas, like really dusty. These findings support the theory that exploding stars significantly contribute to the dust content observed in early galaxies, enhancing our understanding of cosmic dust production and distribution. James Webb has discovered a space web comprising 10 galaxies dating back to approximately 830 million years after the Big Bang. This early cosmic web formation offers insights into the universe's large-scale structure and the role of gravity in shaping matter distribution. This is a detailed infrared image of the Barred Spiral Galaxy located approximately 20 million light-years away in the constellation Virgo. This observation highlights the galaxy's central bar structure, composed of stars funneling gas towards its core, thereby fueling star formation. We have detected a massive water vapor plume emanating from the southern pole of Saturn's moon Enceladus. This plume extends over 9,600 kilometers, making it 20 times larger than the moon itself. The observation provides direct evidence of how Enceladus's subsurface ocean contributes water to Saturn's entire system, including its rings. James Webb has provided an unprecedented view of a mini Neptune exoplanet located approximately 40 light-years from Earth. Observations reveal a highly reflective atmosphere, likely composed of a thick layer of clouds or haze. The planet's atmosphere appears to contain significant amounts of water vapor, suggesting a steamy environment. This is a super bright infrared galaxy. It's created by the merger of two spiral galaxies. Located 250 million light-years away in the constellation Serpens, this is the nearest ultra-luminous infrared galaxy to Earth. The collision, which began about 700 million years ago, has triggered an enormous burst of star formation, with approximately 200 massive star clusters concentrated in a region spanning 5,000 light-years. We have captured new details of Cassiopeia A, the youngest known supernova in our galaxy, located approximately 11,000 light-years away in the constellation Cassiopeia. The high-resolution infrared imagery reveals intricate structures within the expanding debris field, including bright knots of material and diffuse emissions, offering new insights into the aftermath of stellar explosions and the processes of element dispersal in the universe. James Webb has measured the day-side temperature of TRAPPIST-1b, a rocky exoplanet located approximately 40 light-years from Earth. Using the mid-infrared instrument, scientists determined the planet's day-side temperature to be about 232 degrees Celsius. This high temperature suggests that TRAPPIST-1b lacks a significant atmosphere to redistribute heat from its star, indicating a barren, rocky surface. This is a star that's about to blow up. Wolf-Rayet stars are massive, bright, and short-lived, with only a relatively brief existence before exploding in a supernova. This is a deep-field image of Pandora's cluster, revealing 3 massive galaxy clusters merging into a megacluster. This merger creates a powerful gravitational lens, magnifying more distant galaxies and offering insights into the early universe's structure and evolution. This is an asteroid measuring between 100 and 200 meters in length that sits within our main asteroid belt between Mars and Jupiter. It's nothing special, it just demonstrates that James Webb can see relatively small things in our solar system, like asteroids that might someday hit the Earth and destroy an entire city, so that's good to know. This is the dusty disk left behind when planets collide. The observation utilizes Webb's near-infrared camera and marks the first time this disk has been imaged at these infrared wavelengths, revealing its inner regions with exceptional clarity. Here we have a dynamic star-forming region located 200,000 light-years away in the Small Magellanic Cloud. The near-infrared camera aboard Webb revealed an abundance of dust and hydrogen clouds, which are essential building blocks for the formation of stars and planets. James Webb has unveiled previously hidden jets and outflows from young stars within the cosmic cliffs of the Carina Nebula. Utilizing its near-infrared camera, Webb detected molecular hydrogen, a key star formation ingredient, illuminating the early stages of starbirth. Here we have the intricate structures of the Southern Ring Nebula, which are the result of interactions involving at least 2, possibly 3 previously unseen companion stars. By combining Webb's infrared imagery with data from the European Space Agency's Gaia Observatory, researchers have previously determined the mass of the central star before it expelled its outer layers to form the nebula. This multi-star interaction has led to the nebula's distinctive oblong and curvy shapes. James Webb has captured a haunting mid-infrared image of the Pillars of Creation, a star-forming region within the Eagle Nebula. Unlike previous images, this view emphasizes the intricate structure of the interstellar gas and dust without capturing starlight. This is a cluster of massive galaxies forming around an exceptionally red quasar from 11.5 billion years ago, which is a young, active galaxy that's shrouded in cosmic dust, giving it a red color. The discovery offers insight into the early assembly of galaxy clusters and the development of the cosmic web. Here we have an image of at least 17 concentric dust rings surrounding a binary star system. Look familiar? These rings form every 8 years as the 2 stars approach each other in their elliptical orbits, causing their stellar winds to collide and compress gas into dust. The resulting dust shells expand over time, creating a pattern reminiscent of tree rings or a fingerprint, each marking a specific period in the star's orbital history. James Webb and Hubble teamed up again to capture detailed observations of NASA's double asteroid redirection test impact, marking the first instance of both telescopes simultaneously observing the same celestial event. The DART mission involved intentionally colliding a spacecraft with a small asteroid to test planetary defense strategies. James Webb has provided the clearest view of Neptune's rings in over 30 years. The near-infrared camera captured distinct images of the planet's narrow rings and fainter dust bands, some of which haven't been observed since Voyager 2's flyby in 1989. The images also reveal 7 of Neptune's 14 known moons, with Triton appearing particularly bright due to its icy surface reflecting significant sunlight. Here is one for the arachnophobes, the Tarantula Nebula. Webb's near-infrared camera has revealed tens of thousands of previously unseen young stars, providing unprecedented insights into the early stellar development. And lastly, here is a detailed infrared image of the Cartwheel Galaxy, located approximately 500 million light-years away in the Sculptor constellation. This rare ring galaxy, formed by a high-speed collision between a large spiral galaxy and a smaller one, features a bright inner ring and an expanding outer ring, both sites of intense star formation.